Okay, let's go all the way to your generator software. Can you guys fire your gen software, please? Your generator software is from Cummins. To get the generator software, we need to do two things. Number one, you need to have your load calculation handy, electronically or a hard copy. And you also need to have the mechanical schedules ready to go. Can I have thumbs up when you guys are ready? Mechanical equipment, as well as the generator. When you guys open the software, it tells you, do you want to register? You can register at any time, but you don't have to. Are you guys there? Everybody's there? Open the software. It should be Power Suite Gen Size. Power Suite Gen Size. Power Suite Gen Size, trademark of Cummins. Cummins make generators, medium and low voltage generators. And what you guys are going to be doing is sizing a generator for the commercial building. We have a backup generator, 100%. Our gen that we size for this building is going to back up this generator 100%. I know you guys, the service that we have is a 500 amp panel. You could easily take a 500 amp panel, multiply it by 208, multiply it by 1.73, and get the kVA. That's not how we size generators, though. Because generator is sized based on two things, Rob. Two things. The running load, how many loads are you planning on running at the same time? And actually, the second thing is they size it based on the starting load. How many loads are you planning on starting at the same time? Two things: running load and starting load. Okay. All right. Can you guys hit on project, new project, where it says new? Everybody can hit the project in the middle here. Can you guys see that? Oops. Why don't you guys tell me that? Oops. Alani, what have you done? I'm looking at my screen thinking that you guys with me here. All right. Almost there. This software is so easy. So easy. Load calculation and the schedule. For your schedule, my friends, if you do me a little favor, and for your schedule, go all the way to the mechanical schedule. The mechanical schedule, and that will be in page 12. Page 12. Can you guys see page 12 in your page 12? Okay, everybody's there, right? Everybody at this point. Can I have thumbs up, guys, when you reach so we can open the software? If you guys go ahead and open, double click on the project. Can you see a project right in the middle here? Double click on this. Now you should see an interface that gives you a project. You are ready to start a project. You're ready to start a project. In order for us to do this project, we need the following. We need the load calculation. And I grabbed my friend's Dustin load calc here. You need your load calculation. For load calculation, guys, if you remember, we have a receptacle panel, lighting panel, and main panel. And I'm interested in the kVA for the receptacle panel and the lighting panel. The kVA for receptacle panel as well as the lighting panel. Okay? So that's all what I need. Receptacle panel and lighting panel kVA. So, all right, so that's the first thing you need to do. The second thing you need to do, my friends, is schedule. So you need to go to your schedule. Let's go directly into narrative, design development, and we're going to go to the narrative. Here you go. So you should be looking at the receptacles. Come on, buddy. All right. Okay, mechanical. You should be at the mechanical equipment. I want to use the mechanical equipment and the load calculation. Cool? All right, so you have them. Everybody have these two. The mechanical equipment, this one, I'm going to be picking some stuff from here, as well as the load calculation. All right, so let's go back into my software. If I can find it. Where did I hide it, Chad? Here you go. Okay, when you come here, guys, expand this, so you're going to see a few things. You're going to see in this software, you're going to see a new project way at the top. Can you guys see a new project? Loads and steps. Loads, you're going to add all your loads. You're going to see how I'm going to add them. Steps, you're going to add a step, meaning you're going to start this load at the same time. If you put all the loads in one step, this is you're telling the software that you want all these loads to start at once. That's the worst scenario for any generator. You want to split them into steps. But the problem, I want to remind you guys, the riser that we have, remember the riser that we have? What do we have? We have an auto transfer switch. So when I lose the power, what's going to happen to my building? When I lose the power, the generator is supposed to come and the whole building will be shifted completely to the generator. So how many steps do I have? One step. A step is an auto transfer switch. So sometimes we have 1, 2, 3 auto transfer switches, guys. We transfer the emergency system first. We wait 10 seconds. Then we transfer the legally required standby system. Wait 10 seconds. Then we transfer the rest of the loads. Does that make sense? A step is an auto transfer switch. How many auto transfer switches do we have? Only one. Not when you go next project, guys. When we do it with Michelle Cooley Erickson, we have a step is a step is a power circuit breaker. Power circuit breakers also can work as a step. You can turn them on and off at certain time. Okay, so let's start with the following. Let's go to a project. Can you guys see where it says project? Project. Let's go put some information about the project. Let's just say project edit, and when you go there, let me go one more time. Let's just see something about the project. You go project edit, and this is the parameters. You have only one project. Next time when we do this software, if you want to parallel, this is where you parallel generators. We have one generator. They have some defaults, guys, rated and so forth. So accept this. This is just information about the generator. The most important thing right here is the voltage. Can you guys see where the voltage is? What's the voltage of the system that I have? I have 28120, right? So I'm going to go all the way down to 28120, 122.8 parallel. Can you guys see that? Everybody can see where. So my generator is going to be 122.8 parallel Y. Everybody pick that generator, because that's the generator that we're going to have. The voltage. What type of thing we're going to burn in this baby? You have diesel, propane, and whatever that natural gas. We're going to go diesel, unless you know it's always diesel. Frequency, we are off frequency standby. Everything that you can see right here is default. The only thing you need to pick as of now is the voltage. Everybody picked 122.8 parallel. Cool. 122.8 Y. It's a Y generator. Right? Okay, good. So all the rest of the information, guys, look at the altitude. If you are going to put this at 10,000 feet, I'm going to leave Jerry talk about all the altitude derating and so forth. If you put it at a higher altitude, they derate the generator. For the time being, the only thing you need to worry about right here is the number of generators in parallel, 1, meaning how many am I running to at the same time? 1. And what's the voltage? Can I have thumbs up? We got this one, the voltage. Okay, yep, we're good. Go to the project again. Set number of steps, set generator size. Okay, we don't want to do that one. Oops, we're not there yet. Okay, we got the report, edit, generator size, set. Okay, so view. Let's go directly into my project. Can you guys click on the project right here? I'm going to go add the lighting panel. I'm going to add a lighting panel. Cool. So I have a big chunk of load called lighting panel. So based on my friend Dustin's calculation, here's my lighting panel that Dustin came up with. 67,000 square, 67 kVA. Can you guys see that? It's a 67 kVA. 67 kVA. Yours is going to be slightly different. 67 kV. So I'm going to have 67 kV with a little bit of cache. And by the way, this is coming from all the way up to lighting panel. Can you see it? The phase, the one that you need for the phase, not a neutral. 67. So let's go here. Lighting. Can you guys see where this bulb is? Where it says bulb here? Can you see it? Click on that baby. All right. Open it. So when you are here, I want you guys to type lighting panel LP. Cool. Type LP. Go all the way to kVA. Click. You can put the load in kW, kVA, or amps. I like kVA, so click on kVA. What did we say the kVA of that system? 69? 67. 67 kV. So I put my kVA 67. There's one little problem here. What's the voltage? 208. So I need to go change this to 208. There's one little problem. Is it single phase or three phase system, this panel? This load is a big chunk of load as one big chunk of load. Is it three phase? It's a three phase, right? I know the loads are single phase, but all of them as a panel are seen as what? Big chunk of three phase. Can you guys put 67 for the time being? You can change it to match yours. The voltage is 208 and make sure it's three phase. What type of light? Now look at my options. I can have incandescent, discharge, or fluorescent. For the most part, and this is why we're going to split hair here. We're not going to split. For the most part, what type of light we used in this building? Fluorescent. So pick a fluorescent. Most of the time, going to be fluorescent. That's it. Everybody's at this point. Can I have thumbs up? Yep. Go next. Now, can you guys see what the system is doing? It's calculating running kW, starting kW. It's the same. There's no air rush for lights. All right. So let's go directly to the next step. Next step, it tells you power factor. It assigned actually a power factor of 95 for all these lights. That's good enough. For fluorescent, 95 power factor for all these ballasts is good enough. You can change the power factor. Can you guys see the running and the starting power factor? Leave it as is and hit finish. My friends, you have just assigned a lighting panel to be powered by your generator. Can I have thumbs up? Good. Let's go receptacle panel. Let's go to a receptacle panel. Okay, receptacle. Look at the loads that we have here. Okay, can you guys see that little guy here? Look at my option. My option is light, air conditioning. Receptacle is not an air conditioning. Battery. I have medical. I have motors. I have fire pump. I have UPS. The only option I have for receptacle is under miscellaneous. Can you guys see that? Click on miscellaneous. What type of load do I have? Can you see it says general receptacle? Can you guys click on general receptacle? When you click on general receptacle, go to the name and do me a favor. Call this is RP. This is my RP panel. Now I need the load for this. RP. I need a load. So you're going to go based on my friend Dustin. What's your name again? Based on my friend Dustin, I have 29.7. I'm going to say 28,000. Can you guys see that? That's from Dustin. 28 kVA. I'm sorry, 29.730. Can you guys see that? From the load calculation that Dustin have, he has 29.7. So that will be 30 kVA. Can you guys see it? Do I need to blow it more? Right in here? Yes, sir. Okay. All right, let's go here. And the only option that I have, first of all, let's change the voltage to 8. You don't have an option, but that 30 kW kVA, assuming the power factor is the same. Okay, so we put 30 kVA kW. The only difference is what? The power factor. You know, if the power factor is 95%, guys, you're off by what? 5%. We can live with that. Life is not perfect, remember. So 30, 208. Everybody got that? Okay, I'm going to go to next. Next, the power factor is 90. They're assigning a power factor of 90 for receptacle. Leave it as is. Now this is where you guys can get the power factor. Leave it as is and hit finish. And I have just assigned a receptacle panel for this generator. Can I have thumbs up? Yes, Chad, we can do that. All right, let me go get rid of my email because it's bothering me. Okay, so I have my receptacle panel. I want to remind you guys, the lighting panel has all the lights. The receptacle panel has what? All the receptacle plus what? Mechanical equipment. The only thing left right now is what? The only thing left in this that we need to feed from is anything that's fed from the main panel. What was fed from the main panel? The lighting panel done, receptacle panel done, the chiller, the two chillers, the two pumps. So we need to go accommodate for the two chillers. So if you guys go to page 11 circled here, so we accommodated so here's I want to take you guys right here. Do you see where it says electrical service? Phil, say electrical service. Can you guys see what's fed from the main distribution panel? I accommodated for the two panels. Can you guys see the two lighting and receptacle panel? UPS, we said this is we did it differently. The three things I need to accommodate for are these. Oops, let me do them in a different color here. I need to accommodate for air handling unit, condensing unit, boiler pump 1 and boiler pump 2. Why? Because lighting panel and receptacle panel covered everything else. You're going to ask me, Chad, what happened to all the mechanical, smaller mechanical equipment? We threw them where? If you did your lighting load calculation right, they were thrown into the receptacle panel. They're accommodated for. All your mechanical equipment, smaller equipment, were actually fit from the receptacle panel. The only thing that was not are these four things. So I'm going to go add these four things. Can I have thumbs up, Chad? We got it? The question is, where are the other mechanical equipment? For example, what happened to all this stuff, Chad? Right here, the recirculating pump. These are fed from the receptacle panel, and the load that we picked, 30 kVA for the receptacle panel, already taken care of. Okay? All right, so let's go back. Where am I here? Oops, a mess here. Let's go back and let's go back, guys, and accommodate for one at a time. Accommodate them for one at a time. All right, Chad, here you go. Okay, the first thing I want to look at is air handling unit. Air handling unit, right? The first one is air handling unit. If you guys look at this one, it says air conditioning, right? That's what I'm going to put the air handling unit. Click on this one. I'm going to call this is, well, it's actually air handling unit. I'm sorry, I lied to you. Go back, go back to motors. What's your name? Can you see where it says new motor, guys? Because the air handling unit is nothing but a big fat motor. It doesn't have compressor in it. Air handling unit is just a motor. I'm going to go ahead under motors, click on motors. I'm going to call this is air handling unit, right? Horsepower. What's the horsepower of the air handling unit? You're going to go to the list, right? And from that list, the air handling unit is 15 horsepower. 15 horsepower. Oops, not 16, Chad. 15 horsepower. What's the voltage? It's a 208, Chad. 208. 3-phase. Okay, now the question is, can you guys see the start? When it comes to motor are very important because they have inrush. We need to accommodate, Phil, for the inrush in the motor. So they ask you, how do you want to start this motor? How do you want to start this motor? Because based on the way you start the motor, the generator can be that big or that big. Because so that very, when it comes to major generator, when they say major motor, guys, when they say major motors, anything 10 horsepower or larger, you need to pay attention to the start. The baby ones, the 2 and the 3 and the 4 and the 5, not a big deal. You get into 10 horsepower, 30 horsepower, these are substantial. We need to pay attention to the inrush. Okay, look at this. My options are NEMA Design BCD. This is the dumb NEMA across the board. But what type of control am I using though? Can you guys see the air handling unit shall have a VFD? Can you guys see the VFD? So I'm going to go, can you see where it says VFD here? Click on VFD. When you go to the VFD, they have two options. You have conventional AC inverter or pulse width modulation. I like pulse width modulation better, so go pulse width modulation. The best technology. Cool. Pulse width modulation. Okay, any comments? You can write here any comments you want. Can I get you to you have the voltage, you have the horsepower, and the starting as pulse width modulation VFD, right? All right, go next. I want you guys to look at one thing here. Uh, can you guys see the running kW and the starting kW is the same? Can you guys see that? Let me just get you to do something else. Go unclick the VFD, will you? Unclick the VFD. Unclick the VFD. Rob, can you see what the running kW in this system? 12.8. What's the starting kW? 43. Do you see the difference? Major difference between having a VFD on a piece of equipment and not having a VFD. If you guys look at this one here, look at the running, 12.8. The starting is 43. So this is like, say, 13, and this one is here, 43. So 4 times, like 4 times, the running. The starting, it takes 4 times more effort to start this pump across the line with NEMA than to run it. Now, that's if it's NEMA though. Take this, close this here. Go back to VFD. I want you to look at this one. Go back to the VFD and go back to the pulse width modulation. Actually, can you see the start and the running is what? Equal. Because VFDs, what do VFDs do? They reduce the frequency and the voltage proportionally to the torque, so you can easily, smoothly start your pump, ramp it up, come up to speed, and ramp it down. So when you start slowly, gently on the motor, on the generator, it doesn't have that shock to the generator when you start this load. Very important. So if you want to have a generator size really good, VFD is a good start. Okay, everybody knows why VFD, what the VFD does? It reduces the inrush. Who cares? It will make the size of your generator, believe it or not, smaller based on the inrush. Okay, so go next. Next, it will tell you they're going to assign a power factor of 90. Accept that one and hit finish. I have an air handling unit. Yes, sir. Go back. By the way, you can double click on it to go back and finish. Load cycle on off. If you know that your load is going to be a cycle every 15-20 minutes, you click on that one. So meaning it's going to be starting and stopping more often. This is continuous. It runs and it might run for an hour, 2 hours, 3 hours, and then stops. Okay. Any question guys about air handling unit? So we got the air handling unit. The second thing we need to do, Ashley, is the chiller. We have 2 chillers. We have one future and one day one. So I'm going to call it, can you guys click on that little icon here, new air conditioning? Can you see that? Hit chiller. When it comes to here, I want to say, what, do we have a chiller? We have condensing units. CU-1. I'm going to call this one CU-1. There's one problem. They're asking about the ton. If you guys go back to the, believe it or not, if you go to the description of that, it will tell you how many tons is this piece of equipment. It's 10 ton. If you guys go to page 19 here, page 19, it says 10 tons on that list right here, 10 tons. Chillers, they rate them in tons. So I'm going to go put 10 tons. 10 tons give me like a 19 kVA. 10 tons. Everybody knows where the 10 tons came to be? From the cut sheet. Now, actually, if you don't have a cut sheet, what do? You know what I do, guys? If I give you a Jackson, my friend, you keep putting numbers here until you get the kVA that you're looking for, right? You keep putting, guys, numbers until you get the kVA. Like you can change this number. If I want this one 20, let's just say 15. If I put 15 here, I'm down at 28, right? Maybe I'll move this one to 13. So that's what we did. If you look at 24, right? 12, I'm closer. 12, 22, maybe 11. Okay, 11, right here. If I want a 20, I just put 11 here. So you can play with the tons to get you the kVA. One more time, I'm looking at, right, the values that I'm comparing is this value here with the ton. So you keep playing with the ton until you get the kVA of your equipment. How do you get the kVA of your equipment? If you need the rated load amp multiplied by, so you have the rated load amp condensing unit, 80, you're going to take the 80 81.6 multiplied by 208 multiplied by 1.73 divided by 1,000. That's for this picture. I don't know if this will give us the same amount, guys. Anybody does that? Go ahead. Let's do the math on this one. 81.6 times 208 times 1.73 equal divide by 123. I have 29. I have 29 kVA. And what's the kVA that I'm looking for? Yes, sir. Go ahead.
Well, before we content, kind of combine each one, the existing one.
No, we're going to put them separate.
No, I know, but you got 10 tons on this one, that's the future one, and you're using the RLA.
Oh, I'm sorry. I'm using, that's why I'm off. What was the regular one?
The future one was 34.8.
Yeah. The condensing unit. I want this condensing unit, guys. The condensing unit, not the future one. It says actually 20. It says 20 horsepower, 20 ton. That makes more sense. Can you look? I'm looking at 29 kVA. So let's close that one. I want to have a 20. 30. Running kVA is 37.25. Don't ask me. I go by tons. If you know the tons, guys, go by tons. Good. Ah, that makes a difference. Thank you. 208. Am I in here? Okay, still this conversion is just power to power. So since we have 20 tons from the cut sheets right here, thank you, Phil. The 20 tons is for the cut sheets. But we change it the 2534E. 4E. Okay, so we have 20 tons. Can you guys put 20 tons? Okay, cool. All right, next. Now, what type of a start in this baby? If it's a chiller, almost always VFD. So click on the VFD and put pulse width modulation and hit next. The same thing, guys. Power factor and finish. I have chiller number 1. Right? I have chiller number 1. Right click on chiller number 1 when you're done, guys. And can you see what it says copy? Copy. And right click on the load and paste. So now here's a chiller number 2. It gives you the same information. You can copy a load. One more time. So if you go right click on the chiller and copy it, go to the load, right click and paste it. You can paste that. So then double click on the new one and name this one. I'm going to call it CU-2 future. Right? CU-2 future. This one was 10 for sure because we just played with that one, 10. So when you copy, Rob, you don't have to modify anything. You can copy the same load. So if you have 20 motors, like next project, guys, we're going to have tons of machines, all the same. All the same. So what I'm going to do, I can copy them. Keep copying them. Okay, so next again and finish. Oh, we did 10. If you want to go back and edit any one of them, guys, double click. You can. Oh, thank you. Put 10 here. Yep, thank you. And finish. So one of them is at any time, Dustin, you can come here to the lighting panel, double click on it. You edit all this information. You can come to the future, edit all this information. Can I have thumbs up, guys? You have 2 chillers and an air handling unit. Yes? 2 chillers, air handling unit. What's the left? Pumps. We have 2 pumps, right? We have pump 1 and pump 2, right? So let's go pump 1. Pump 1 and pump 2, both of them are 2 horsepower, right? Both of them are 2 horsepower. So Tom, my friend, I'm going to go, the pumps are motors, so click on motors. I'm going to call these pump, what did they call them? Boiler pump. They'll go BP number 1, Okay, what's the horsepower of that baby? 2 horsepower. And what's the starter? Actually, it says the starter combination starter disconnect. Combination starter disconnect, guys, is anema. Combination starter disconnect is anema. So do I need to go VFD here? No. Leave it as is. Okay, there's my horsepower. Go next. Now, for motors, it gives you all this information, the lock rotor current. Leave it as is. Leave everything as is. Unless you know otherwise. Leave the NEMA letters and everything else. Let me go back. Any question, guys, about this? I put pump number 1. Oh, 208. Thank you. There's a 208 here, Chad. 208. My load is 208. It's 208, 3-phase, right? Perfect. Everything is cool. I'm going to go next. Leave as default everything else, unless you know otherwise. Can I finish? Across, can you guys see what it says across the line? For those of you, did you guys do all delta Y and what do you call them? Part winding. I know actually you did if you did our motors. There are different types of across the line start, or there are different types of non-reduced voltage start. Part of them across the line is the worst. Y delta. If you don't know Y delta, if you don't know anything, you just leave it across the line. Across the line is just like this. That one is called across the line, meaning you don't reduce the voltage as you start your motor. So 99% I guarantee is going to be across the line. Leave it as is and hit finish. Power factor running and hit finish. Now I have one motor, but both of them. So if I right click here, and I'm going to copy again because they're the same. And I'm going to go to the load again and right click and paste it. So I have 2 motors. The only thing I need to go right now is just double click on it and rename it. What do you think I'm going to rename it? BP-2 because identical. They're identical. And finish. I have 2 pumps, 2 chillers, an air handling unit, and 2 panels. Do I have anything else I need to add to this building? That's it, right? Because Dustin, do you remember how if all the lights were fed from lighting, all the receptacles and the smaller mechanical equipment were fed from the receptacle panel, the major equipment were fed from here. Okay? Any question? Now, for next project, don't do that. For next project, guys, suppose I have a UPS system. See what it says uninterruptible power supply. Do this for an exercise. Go click on this. I'm going to call this one UPS number 1. The output kVA of this UPS is 20 kVA. The voltage of this baby is 208. I'm going to delete what I'm going to do. It's 6 pulse modulation. Leave it as is. Next, UPS, and I take the default and finish. I have a UPS load. This will be important for next project, not this project, because I don't want it in my load right now. What do I do with it? Right click on it here, and do you see where it says delete load? Get out of my face. Done. Okay. All right. Done. All the loads are done. Now we're not done yet though. The loads are done. Steps. Let's go. How many steps do I have? Any question about the loads? If I have more loads, what do? Keep doing the same thing. Add loads, add loads. If I want to edit any load, double click on it. Anytime. Anytime. Double click on any of these. You can edit any load at any time. Cool? Let's go to the next step. Any question, guys, about adding loads? Can I have thumbs up, Chad? We know how to add loads based on the type of the load. Okay, Ashley, Tao, you guys are good? Okay. So steps. I only have one step. Do you remember what I told you guys about step? A step is 2 things. Auto transfer switch. How many auto transfer switch do we have? 1. So all our system are going to be on 1 step. Okay, so look what you're going to do. You're going to drag them, pick one, hold shift, pick the, oops, it doesn't allow you to. You're going to take them one at a time, hold them, see where I'm holding them, and drop it here. Do you want to put it in this step? What I told the software is I want to start the lighting panel on step 1. Okay? Hold the left shift on this, the left click, hold it, and put it right on the step. Now I'm bringing the panel, the receptacle panel. Same thing for this. I'm going to bring it to step 2, and the same thing for this. And you just keep basically bringing them to this step, all of them, right? Okay, and all of them. Okay, are you guys with me? Does it make sense? Drag them all to the same step, step 1. Okay, so what I have done, guys, I've told the software all of them are going to start at step number 1. All of them. So if you click on the step, I think you can, so expand the step. I think you can rename the step. A new step, edit step. I don't want to edit the step. I don't know if I can rename it. All right, so step number 1. Everything is going to be on step number 1. Why do we have only one step? Because our project has only one step. Now, let me just tell you what happens if I have 2 steps. If I have 2 auto transfer switch. Can you guys see the little icon here? Way at the top. Can you see it? Here's one more step 2, step 3, step 4, step 5, step 6. Every step is an auto transfer switch or a power circuit breaker. Just FYI, I want you guys to not do that. Look at this. Suppose I want to go take my lighting panel onto step number 2. Look what I do. Grab it and dump it onto step number 2. It says move it. What you have told the software is, you told it start everything else. After 10 seconds, come back and start the receptacle panel. Okay? I don't want to do that. So remove. I want to delete these steps. Can you guys see where it says go to the delete steps? Steve, I want to go right click, delete steps. Yep, I don't want it. I only one step. One step. Not edit, Chad. Delete. I think you can highlight all of them. No, you can't. Delete steps and delete steps. Okay? Any question, guys, about adding a step and delete step, and why do we have only one step? One auto transfer switch. Rob, next project, when we do the commercial industrial, we're going to have at least 16 steps for all the loads that we're going to be adding. It's a 4,000 amp switch gear. We're going to bring it at different steps. Everybody knows what a step is? A step is a chunk of load that will start at the same time. So you grab a panel, energize it, within 10 seconds, it's up and running, then you put it to the side. You grab another chunk, energize it, within 10 seconds, put it to the side. Does that make sense? Okay, I want to go delete the step number 2, guys, because I don't have step number 2. Any question about step number 1 and the loads adding them? You're done. You are done. You put your loads and you add your loads to the step. If you want to delete a load from a step, you right click on it and delete a load from a step right here. If you edit, when you edit them, always edit the loads right into under loads. Actually, you can edit them anywhere else. So step number 1, we bring the loads, we assign them a step, we're ready to go size the generator. Any question? Any question? Let's go size the generator. So second thing, can you guys see with that little icon here? Right here, everybody can see that? It says size generator. Hit the icon. Now it's cook. It's cooking for you to size your generator. Here's your generator set performance. Model 125DGDK. That's your generator. Can you guys see the... One more time. If you want to go back, guys, if you want to go back, just go click on this icon here. Go back. Here's my generator size. Click on sizing generator. It opens this window for you. Are you guys all at this step? Phil? Rob? Okay. Let me just walk you through what this means. Can you guys see what it says generator set requirements? I have a 480. My generator is wrong here. Is yours say 480, guys? Everybody? Okay, now we did something wrong. Let's go back and change this. Let's go project, generator set. Can you guys see project size generator. Oops, I lied to you, not this one. Go back here, click here. We need to do the parameters for that baby. Let me see if we put the project here. Here you go. Edit. Okay, do me a favor. Go back to that view. Cool. Click on the project. Click on the new project. This should be blue, right? Cool. All right, so let's go. When you're here, go to project, edit, select project parameters. Can you guys see where it says select project parameters? The project parameters right now, you can say anything about. So here's the generator. That's why it's not showing it. You're going to go all the way to 28120 right here, and one generator. Okay, it. One more time. To do the step that I'm doing, guys, you have to highlight the new project. Okay? Is it blue? Yeah. Then go to project, edit, and the second one, select project parameters. What we did before, we get size default performance. That wasn't, we need to select a generator for this project. So if click on select parameters. Now, are you guys there? Can you write your name here? Name is Chad Curdy, and comments, commercial project. That's what I expect, guys, on yours. Line 1, you can add anything you want on these lines. Just put something here on these lines now. If you go to the parameter, this is where you set your parameter to 28120. Can I have thumbs up? Yep, we set the parameters, guys. Yep, no. Okay, it. And then hit calculate. Now hit calculate. Now we're going to get the right voltage. My generator size is my generator size. Can you guys see that? This is the most important thing you're going to get. Site rated kVA, kW, and kVA here. Can you guys see that one here? It says size rated standby kW. Your generator is 125 kW. Based on the information that you provided, your generator is going to be 125 kW. Can I guys get you thumbs up to say, yep, Chad, we know? The model of the set is, this is the model. Don't worry about the depths and all this good stuff at this time. Site rated standby kW. Site rated alternator maximum kW. Okay. Running alternator kW, alternator. Okay, so we got that 25. The second thing, guys, is if you look at this information here, here's a 60 hertz, 120, 122.8 parallel 3-phase diesel, all the information about your project. All the setup information is here too. Cool? Can you guys see that? The most important number that you're going to get is that one, 125 kW. This generator is 125 kW. Yes, sir. What's yours? 230, and I'm 125. You know what the differences would be? Probably when I selected the starting for certain motors, you might have selected a different start than mine. I'll check yours. But see, the difference is not substantial though. I have 125 and you guys have what? 230. So that selection is most likely would be by the type of the start for the motors that we selected. I'll look at yours. Okay? All right. So the second thing I want to show you guys is load running. Here's all the information about your load. Your load have 96 kW, 107 kVA. Generator set. Here's the generator set that you need to go buy. It's an engine. There's information about the alternator and the engine. I want you to, Jackson, my friend, I want you guys to hold your horses on this. Alternator and engine. This is the information that when Jerry Boggs comes on Friday, he's going to go deeper into this information. When you buy a generator, guys, generator is made out of three things. Three things. Every generator, they call them generator set. One is the alternator, that's the generator that makes power. The second one is the engine, the driver, the prime mover that drives to generate power. And the third one is the radiator to cool the system. So he's going to talk about all these three, how you put them together to make a generator. So if you look at this is alternator engine, so you're going to have your generator, you're going to have your engine, and you're going to have your alternator here. So this is my engine, and this is radiator. This is your generator. So when they talk about this, they're referring to alternator, this piece, and to the engine, this piece. Any question, and I will refer to the expert Jerry when he comes, guys. You talk about how the system, you need the prime mover. This is where you burn gasoline here to move coils inside, to move the alternator, guys. You know how we generate, right? You have to have a moving coil. So you generate the power from right in here. Right? All the three phase and the neutral that you come. Okay. So this is the information that you need to do. Close this. Okay, so this is report number 1. So before you go, guys, I want you, can you see where it says reports here? Can you see where it says way at the top reports? Don't print, please. Go down preview. Can you see where it says preview? Preview recommended generator or set upload. What you're looking right now, here's what the report that you guys are going to print for Chad from Cummins. This is recommended generator. That's what you're going to print for me. Okay. That's the information. The second one, close. Oops. Close it. The second one, if you go to reports, the one I want you to look is, can you guys see, can you see a report all available? Do you see a report all available? Click on report all available. Oops, I don't want to, I don't want to delete, cancel. I don't want to print. Okay, report, preview. I'm going to go to the steps. So Ashley, from this software, you need to print 2 reports for me. One about the generator size. The other one is about the steps that you imported. Here's the steps, guys. You guys remember how the step that we did? We did only one step. And here's all the loads that you imported for me. Can you guys see the loads? All the loads that you imported for me are right here. One more time. You guys are gonna be printing 2 reports. Here's report number 1, load and steps detail report. That's report number 1. Cool. That will get you everything that you inputted in this software about the loads and steps. Can I have thumbs up? Yeah, we do. Cool. Okay. The second one, the second report that you need to do, close this, exit, go to report, the second report that you need to do is recommended generator. This is the actual size of the generator. And I'm going to, this is my second report where it says recommended generator. Do you guys remember recommended generator was 125 based on mine? Should be here somewhere, it's 125. Alternator KW, maximum steps, and so forth. Okay. The voltage, the information about your system, and write down, probably you'll find the size of your, this is a recommended report for the generator. Okay, so that's the second report you're going to print. Okay, alternator. Okay, so here's all the information that I need about the alternator, generator set configuration, and so forth. Load requirement, KW for the generator that I'm doing. Okay, here's the KW. My generator is 125 kW. I can send this report to Cummins right now, and they can order a generator for you based on this load. We're using Cummins, guys. Caterpillar has its own generator sizing. Kohler has its own. Every major generator has a software like this that help you. So if you understand what we have done now for this software, you can probably use any other software. Doesn't have to be Cummins. Cool. All right, so when you're done, close this one. You go back, close that, and you go back to your load at any time. You go to size the generator here at any time to look at your generator. Yeah. 480. Okay, you're still here. Go back here. Click on project. Yep. Click on project. And where it says project, go to edit and select project parameters. Select project parameters. Are you there? Click on that one. If you go to the second, general, and then parameters, what do you see at the bottom here? What do you see? Change this one, make sure it says 122.8. Okay? No problem. Everybody else says 122.8, guys? All right. If you go to the library here, they give you some information, guys. I don't know what even in this library that they get you. There's also a spec that comes with it. I think you should be able to get a specification for the generator. Any question, guys, about putting the loads in the generator, assigning steps, hit run, and get 2 reports. Report for the loads, 1 report for the loads, 1 for the generator set. View library. Okay. I don't see where. Go to tool options. I don't have tool. I'm grid here, so I don't know if we don't have a answer to it. It says tool option and you get some reports. You guys will play with it. We use it mainly for the sizing, but you can have a library with it. This, okay, you go. I just didn't go fast enough. You can go to Cummins and you can order a lot of stuff from their website. And I will let, well, Jerry's no longer with them, but this is where you can get all this information about this generator. What we're interested in right now is the size, and you click on the size, and here's the size of my generator. Any question? Is that hard? Easy? What I want you to know, guys, that next we're going to be using this software for this project and next project. We have 2 projects to do this software with. Very easy, piece of cake. Aladipo? Cool. When you're done, you can print. You can print all this stuff, guys. You can print to PDF. You can save them. I'm sure you guys are familiar with Microsoft product. You can save them as a PDF. I think you can save it as a PDF. No, you can save it. Or if you want to print it as a PDF for the presentation, Jackson, you can go print, cute PDF, and you dump all this report in your PDF, and for the presentation, you shine it. Dustin, makes sense? A little bit more. When you guys play with it, you're going to find it's really easy to use. Nothing to it. At any time, you can go back to your project right here. Here's the library, Cummins product. If you click on the Cummins product, engine, business, power generation, business, I don't know, power generation. So I want to remind you guys, next project, when we do the industrial, we're going to be visiting Cummins manufacturing plant in Fridley here, and we will be spending 5 hours there, where you tour the factory, and we have at least 3 hour of presentation from their engineers about how the whole system works. So it's really, you're going to enjoy it. So just, that's why we use their Cummins software. Any question? Did anybody was able to get this back? Used to load. I think you can have to their site now. Get this back. Product registration. Okay, before I finish, anybody has any question, guys, about the software? Any question about the software? No questions? Tools, options. Okay. Cancel. Joe, right here, before you leave, please go File, Save, and name it Commercial Project. Commercial Project. And before you leave, and go all the way to your team folder and put it under generator. Team folder. Generator sizing. Everybody see what generator sizing? And please save it right there. Commercial has been saved. So now you have a copy of it. Now when you open it, guys, you have to open the software first before you open it. I don't think you can double click on it. I might be wrong. You can't? Okay. So you have to open the software first. Go grab the file from the online. Can I have thumbs up? Yes, Chad, got it? Cool. Okay, great.